Hello, how are you guys?
Hello.
Um, Today, at the end of the class session, after we finish, then so those of you that have up to 70% attendance can request for makeup for 5 assignments, not more than 5. Now, if your attendance is not up to 70%, that means you cannot request, but you still have time from now till December to push it up to 70%. That will now qualify you to request for makeup assignments. All right, let's begin. And this week, we begin the study of test of hypothesis. Let me show you my announcement for the week. So I'm going to share the screen with you. Okay.
Sorry, Professor, can I say something before you start?
Yeah, what do you need?
Classwork 9 is still not showing
Yeah,
anything.
yeah, yeah. Remember what I said last week? It's the same thing, but I'm gonna put something there tonight when we finish.
Oh, okay.
Mm. Yeah, last week I was moving them forward so that I want to at least finish grading the old assignments before I can put a new one, a new classwork. But
Oh, okay.
now that I have done so, it's the only one left, so I put one in there after this class. Okay. Um, so this is for this week. We begin chapter 9, which is the test of hypothesis. And there are 2 assignments, actually one assignment, because the other one is a project. Three. When I put the second one is not here yet, because that's the classwork. This one, part B, is the group project. And that project is due in December 1st. So it's not included among the one that are due this week. Okay. Now, then the other one is homework 9. So you can start early, but it's due next week. So, of course, you know already that you can have access to this by going to the models and then scrolling down to where the week is. Work 9, semester project, and classwork 9. Now, the project is a group project, like I said. I have not received any response from you about the group you want to work in. So I may have to put you guys in a group by myself. Otherwise, you can still exchange your information in the chat room, the group there, so that you can send me the email about the members of your group. Okay. Now, having said that, we can begin. What we have today is, like I said earlier, is the topic that is called test of hypothesis. Okay. Test of hypothesis. In statistics, a hypothesis is simply defined as a claim about a population parameter. Now, that claim may be true or false, but it is the work of the statistician to analyze the claim and figure out whether it is, true or not. Now, during the testing of hypothesis, what the researcher or the statistician does is to define the population and specify the parameter under study. When we're talking about population parameter, like I explained when we are doing confidence interval, we are referring to this population mean, population standard deviation, population proportion, things like that. So once you identify the population of study or the target population, or the parameter of study, you can now state your hypothesis that you'll be investigated. then give the significance level that we call alpha level. We did this, I introduced you to alpha when we did confidence interval. Select the sample from the population, collect the data, perform the necessary analysis or statistical tests, then reach a conclusion. That's what you do. And we can use this statistical method to answer many questions in the health, business, education, many fields of human endeavor. Most field, every field of human endeavor, I would say, that we can collect data on. We can use the statistical hypothesis testing method to analyze those data. So the questions that I address, I put 3 here, but there's more than that. Does a particular medication lower patient blood pressure? These are some of the questions we can address through hypothesis testing. Does seatbelt actually reduce the severity of injuries caused by accidents? Does the public or customers prefer a certain color in a new line of fashion? So this kind of question we can answer. We can collect data, analyze data, and be able to answer it. Okay? Now, so we are now ready to look at the types of hypotheses. We have the null hypothesis and the alternative hypothesis. We use HO to represent null hypothesis, and we use H1 to represent alternative hypothesis. So null hypothesis and alternative hypothesis, they work in opposite direction. The null hypothesis simply means a statement that the value of the population parameter, such as the mean, proportion, variance. So it's a statement that value, the value of the population parameter is equal to some claimed value. Normally we use the symbols equal, equals, or greater than, or equal to them, or less than, or equal to any symbol with some kind of equality. We use it to state the null hypothesis. The alternative hypothesis is saying the opposite of null hypothesis. And we use this symbol, not equal to, greater than, or less than for the alternative. So you cannot use these symbols in the null. In a similar vein, you cannot use the symbol for null in the alternative. Yeah. So we come back to our hypothesis again when we start, when I start showing you how to state hypothesis. Now let's look at the type of errors we have encountered when testing hypothesis. We have type 1 error and then type 2 error. Type 1 error occurs if we reject the null hypothesis when it is true. So if the null hypothesis is true, but we rejected it, we have committed type 1 error. Okay? If it's true, but we rejected it, we committed type 1 error. Now, type 2 error occurs if we do not reject the null hypothesis when it is false, which means that if the null hypothesis is false and we do not reject it, we have committed type 2 error. Now, let me use this decision matrix to explain this further. Now, if the null hypothesis is true and we rejected it, we have committed type 1 error. Type 1 error. Okay? If its null hypothesis is false and we rejected it, we made a correct decision. So, but when it is true and we reject it, even though it is true, we committed type 1 error. When it is true, when it is false and we reject it, we have made a correct decision. When it is true, when HO is true, and we did not reject it, sorry, when HO is true and we did not reject it, yes, we also made a correct decision. Okay? And when HO is false, but we did not reject it, we have committed type 2 error. Yeah? Type 2 error. So now, excuse me. Now I'm going to use a real life situation to real life scenario to illustrate it. I'm going to use the jury trial. I know some of you have gone to jury duty before, and when a criminal case is being tried. In the courthouse, excuse me. So in the courthouse, the jurymen are there sitting down, and then the prosecutor present the case, and then of course the defendant lawyer, present their own case. It goes back and forth. Now, but hypothesis testing situation can be likened to that. And in any jury trial, there are 4 possibilities. The defendant is guilty. The defendant is innocent. The defendant is convicted. The defendant is acquitted. This is the 4 possible outcomes. Now, let us say that in this particular case, we say that the null hypothesis can be the defendant is innocent. The alternative hypothesis is the defendant is guilty. Okay. As you can see, now, like I said, the prosecutor present their case, and the jury now deliberates based on the evidence they have. Okay. Now, if the defendant is innocent, but he is convicted, the defendant being innocent means that the HO is true. That's what it means. It means that HO is true. If the defendant is not innocent, it means that HO is true. But if he was convicted or she was convicted, even though he's innocent, that means we are rejecting HO. We have committed type 1 error. 1 error. So HO is true, which is innocent, and we convict, which is the same as rejecting HO. We have committed type 1 error. Now, if the HO is false, that means the defendant is guilty, and we rejected it. That means we convicted the defendant. We have made a correct decision. Okay. Here. Now, if the HO is true, that means the defendant is innocent, and we do not reject it. We do not reject HO. That means we acquit the defendant. We have made a correct decision. Okay. Now, if the defendant is guilty, and we acquitted the defendant, we did not reject HO. That means we acquitted the we let the defendant that is guilty to go. We have committed type 2 error. Type 2 error. Okay. Type 2 error. So that's, so you can see how it goes. So now remember that the defendant, the decision of the jury, this tells you exactly how the jury works. Now, the decision of the jury does not prove that the defendant committed a crime or not. The decision is based on the evidence they have, evidence they are provided. So if the evidence is strong enough, the defendant will be convicted in most cases. Now, if the evidence is weak, even though the defendant is guilty, they might be acquitted in most cases. Bottom line is that nothing can be proved absolutely. So, in other words, the decision to reject or not to reject the null hypothesis does not prove anything absolutely. The only way you can prove something, first, we can't prove it absolutely, but the only way you can prove anything statistically is to use the entire population, which in most cases is not possible. Um, and that doesn't mean that that if there's evidence that if the defendant committed a crime and there's evidence enough that he or she is not guilty. No, not what I mean. And that's not what I mean. What I'm saying that if the evidence is strong enough, in most cases, guilty defendant may be committed. But sometimes we make mistake. Like some witness testimony might be wrong, and then you have the wrong person went sent to jail. You know that stuff. You know that already. It happens sometimes. I see it on the news. So the decision then is made on the basis of probabilities, which means that when there's a large difference between the mean and obtained from the sample and the hypothesized mean, the null hypothesis might not be true. Now, any question on what we did so far? Any question? Yeah, good, excellent, excellent. Now let's look at how to state hypothesis. As I'm doing this part, I want you to put your ears to the ground because your classwork will be based on this. How to state hypothesis. Okay? Now look at this. Let me refresh your memory. Remember that you can state no hypothesis only with equal sign or greater than or equal sign or less than or equal sign. And the alternative is not equal to greater than or less than sign. So having that at the back of your mind, let us state some hypotheses here. One states, it says, state the null and alternative hypothesis for each conjecture. Okay. There is such a thing that if expectant mothers use vitamin pills, the birth weight of the babies will increase. The average birth weight of the population is 8.6 pounds. Will increase is the keyword there, which means greater than. Okay. Then you say the average. I mean, it's for the mean. Average birth weight. It's another keyword. So the first thing to do is to write HO H1. HO is for the null hypothesis and H1 is for the alternative hypothesis. Now, we increase is greater than. You can only use greater than in the alternative. So start from there. Mean, okay, is greater than 8.6 pounds. Okay. It said that the average birth weight of babies will be, but they said that it will increase. So he believed that if they use vitamins, the birth weight will increase. So this is a claim right here. That is a claim. Okay. Now, now you can state the honor since you have this information in. Nor always say the opposite of this alternative. So that means you can use mean less than, but the problem is that you cannot use less than symbol on this side. You can only use less than or equal to. So that's what we're going to use. Mean less than or equal to 8.6 pounds. Okay. And that's answer the question. Now some books might write it in this form. Some books use equal sign for all null hypothesis. And for alternative hypothesis, they use not equal. I mean, they can use greater than or less than, like HO can be stated at mean, okay, equal to 8.6 pounds. Then H1, okay, mean not greater than 8.6 pounds. 8.6 pounds. And that's the claim right here. So both of them are correct, just that, the way they are set. Okay. Now, any question on this? Any question? Okay, good. Excellent. Now let's try another one. Look at this one here. It says here, an engineer claimed that the mean number of defects can be decreased in the manufacturing process for compact discs by using robots instead of human beings for certain tasks. So, say can be decreased is the keyword there. Can be decreased. Okay. Now I said the mean number of defective disk per 1,000 is 18. So you have your HO and H1. Can be decreased. That means decrease. You can only use decrease symbol in the alternative. So mean less than, this time less than 18. That's the claim right there. Note that the claim can also be in the null hypothesis. It doesn't have to be only in the alternative. So this one is going to be the opposite, which is greater than. But since we cannot use greater than symbol, we can only use greater than or equal to. We're going to use mean greater than or equal to 18. And that is it. Okay? That is how we state it. Now let's look at part 3. Okay. Now, it says here that, excuse me, sorry. Part 3, it says, a psychologist feels that playing soft music during a test will change the direction of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, mean score was 3. So in this case, he doesn't know the direction, whether it's going to be greater than or less than. But he said that will change. Will change is the keyword. Will change the result, but he doesn't know which direction. So that means equal sign as HO and H1. Will change, it can be left side or right side. So we don't know which side. So mean is not equal to, because we don't know the direction. 73. And that is the claim that it will change. Then the opposite is equal to. So mean is equal to 73. So that's for this type. When they don't know that direction, I use that. We call this type two-tailed test, but we'll come to that in a minute. Okay. So another one, it can be different for, it can even be for proportion. Like here, it says at least 45% of senior citizens wear hearing aids. This is not mean anymore. This is a proportion. So I say at least means greater than or equal to, and it can only be used. You can use that symbol only in a null hypothesis. So because this one is for proportion, we cannot use mean. We'll use P. I say at least means greater than or equal to. Greater than or equal to 45%. That is the claim, what they're claiming. Then H1 will be the opposite, less than or equal to, but you cannot use the less than or equal to symbol here. You can only use less than symbol. That means you can use less than 45%. Okay. So this gives you an idea of what stating hypothesis is. If you look at number 5, it says more. I want you to get strong on this. So when you do the classwork, you know what to do. It says here, more than 70% of college employees contribute to the United Way corn. More than 70%. More than is the keyword. Yeah. More than. That means greater than. Have P, H-O, H1. So more than, greater than can only be used in the alternative. So you have P greater than 70%. That is the claim right there. The opposite is less than, but you cannot use less than in null hypothesis. You can only use less than or equal to. You gotta have P, excuse me, P less than or equal to 70%. Okay. All right. So this is how it's do. Let's do the remaining two. Maybe one of them you can do the other one by yourself. It says here, the average annual income. Yeah, the average annual income of accountant is 51,497. Is a keyword. Is means equal. Okay. So, and you can only use equal sign in the null hypothesis. So H1. You can only use equal sign in null hypothesis. So the mean, see, is the mean average income. Average means mean. Okay. So that means you can use mean. I have mean equals, because you say is 51,495 from 497. And the opposite is not equal to. Opposite is not equal to. Mean is not equal to, okay? Not equal. This one is a claim right here, because it says is claim. Okay. Mean is not equal to 51,497. So that's how to state hypothesis. Maybe you can try this one as a practice at home. Any question before we move on to the next concept? Any question? Okay. No question. Good. Now let's look at some of the terms we use in hypothesis testing. The first one we're looking at, we're going to look at those that will be relevant to our test of hypothesis. We will focus our test of hypothesis for this class on mean, test for the mean. We might do for proportion as well, but let us take care of for the mean first. It says here, some of the terms. One is the level of significance. The significant level simply means we use alpha to denote it. We have come and did it before when we are doing a confidence interval. It simply means the probability of rejecting null hypothesis when it is true. Remember when I said last week when we were doing confidence interval, I said that if you're 90% confident, that means your chance of being wrong is 10%. If you're 95% confidence, your chance of being wrong is 5%, something like that. So it's the alpha. Level of significance is an alpha. So for example, if the significant level is 5% or 95% confidence level, it indicates a 5% risk of concluding that the difference exists when there is no actual difference, So the simplest way of explaining the meaning of significant level is just to say that it is the probability of committing type 1 error, which is the alpha. Next concept is the critical region. The critical region, a simple way of explaining it is that it is the rejection region. So if your answer falls in that region, you reject it. So now, critical value is the cutoff mark. That's the cutoff point. Is a point on the test distribution that is compared to the test statistic to determine whether to reject the null hypothesis or not. So it's a cutoff point. Now, two-tailed test. A two-tailed test is used if the deviations of the estimated parameter in either direction from the benchmark value are considered theoretically possible. For example, if you look at this is the two telltales. You have left side and right side. You can see the critical region right here. Anything that falls in the critical region, you reject. So this is the critical value, cutoff value. So you have both left and right sides. So you have two tails, call it two tail tests. Now, this kind of tail, to get the critical value, you can use the same method we use for confidence interval to get the critical values. We can use the Z alpha over 2 for that. Now, what we call one tail test. So one tail test can be left tail or right tail. Okay. As we look at this one, consider that the critical region is only on the left side. This is left tail test. If you fall in this unshaded place is the acceptance region. Just like this one is the acceptance region, don't reject. But so long as it falls on the critical region, you reject. Something like here. And here you can see the same thing. This is the right tail test. Okay, right tail test. Make it 16, probably 18. Matter of fact. Right tail test. Call it. Because the rejection region is on the right tail. Okay. Now, with this, we are ready to begin testing hypothesis. Now, to test hypothesis, to run a test, we start with the Z test for the mean. Okay. The Z test for the mean. The process, there are two methods we can use. There's the traditional method and then the p-value method. Okay. For the traditional method, you begin by stating the hypothesis and identifying your claim, then find the critical value from the appropriate table. Then once you do that, you calculate the test statistic. Then after that, you can make a decision to reject or not to reject no hypothesis. I mean, you compare your answer to the critical value. If his answer is bigger than the critical value, you reject the no hypothesis. If it's not, you don't reject. Then you summarize your result. That's why I wrote here that the decision criteria is to reject the null hypothesis if the calculated value, that's the answer, is equal to or exceed the critical value. Okay? And the test statistic we use is Z equals the X bar minus mean divided by the standard deviation over root n, where S bar represents the sample mean, mu represents the population mean, delta represents population standard deviation, and n represents sample size. You know, you have come across this formula before when we are doing a central limit theorem, but we use it as a test statistics for mean test. If you want to conduct hypothesis testing for the mean, I call it Z test for the mean. You will use it as well. Let us apply this in testing this hypothesis for this one. Look at the question here. It says here that at the medical, a research reports that the average annual salary of assistant professors in the year 1997 is more than 42,000. A sample of 30 assistant professors has a mean salary of 43,260. At alpha 0.05, test the claim that assistant professors earned more than 42,000 a year in 1997. The standard deviation of the population is 5,230. Now, somebody who read this question might say, okay, this is, you said that it's going to be bigger. Their salary should be bigger than 42,000. Now, a sample of assistant professors that year has a mean of 43,260, which is bigger than 42,000. So why are you wasting your time running the test? Since this already indicated. Of course, you have to run the test because remember, this is for 30 assistant professors. We have thousands of assistant professors in America. So, and given that we don't know that we give us the population standard deviation as 5,260, we have to run the test. So that because this 30 is too small to represent the average salary of assistant professors in America in 1997. And besides, we don't even know how the sample was collected. You don't even, maybe it's from one school, one college, which does not represent the entire college. So that's why we still need to run the test. Now, to run this test, we need to put our summary statistics together. For some reason, if I came to this page, my course starts malfunctioning. But in any case, I'm gonna figure out how to trick it. Okay, so let me go from here. I'm going to use trick to get it. So let's start writing our summary statistics. First of all, let us state the hypothesis. You need our HO and H1 are the first thing to do. HO and H1. Okay. Remember the case. In this case, they say that there is such a report that the average salary of assistant professors in the year 1997 is more than is a keyword there. It's more than 42,000. That means greater than 42,000. Okay? That's what it means. So we start from HO. Matter of fact, let me move this down so that we have enough because we don't have enough room here. Okay. So we start from there. HO and H1. H1 is more than, we can only use more than, that's greater than in the alternative hypothesis. Let me make this in 18. So you have HO, we have mean, okay, is greater than 42,000. That's our claim. Okay. The mean is less than. Now, you're going to be, the opposite of this will be greater than, but since we cannot use greater than here, we can only use greater than or equal to. That's what we're going to do. Mean is greater than or equal to, oh, sorry, my mistake. It's going to be the opposite, less than or equal to. Less than, it's supposed to be less than, but since we cannot use less than here, so we can't use less than symbol here, we're going to use less than or equal to 42,000. Okay. Now, it says as our alpha is 0.05, so I'm going to copy this. The alpha is 0.01, 0.05. Okay. Now it's less than, greater than, that means is pointing on the right direction. This is a right third text. Right here. This is a right third text. Because the alpha, you see, greater than is pointing on this side, on the right side. So main thing now, let us write down the value we have. You see that the salary is more than 42,000. So mean, okay, sample mean, sorry, population mean is mean equals 42,000. Then standard deviation is of the population is 5,000. Yeah, equals 5,230. Then sample mean, for a sample of 30 professors, then 30 of them N equals 30 assistant professors. And the salary of those sample mean, I cannot get X bar character here, so I'm going to get it from the other workbook. I say it's, let me write this down. It's 40, S bar is 43,260. At least that's what they told us. So I can go and get it from the other workbook, the character X bar. So we got X bar, okay, X bar equals, I'll make this bigger. Make it bigger. Okay, equals 43,000. Okay, let me undo this because I don't know why it's doing that. Okay. Equals 43,260. So I'm gonna copy this from here and paste it there. 43,260. Yeah. So we have all the small statistics we have. So now let us transform this. Now I'm gonna write this down so we can go to the give the formula to transform it and then draw our chart. So n sample size is 30. Standard deviation is 5,230. So I have everything we need. So you can now remember the formula we're using. We're using this formula here, this one here. So I'm gonna go to the take it to the other workbook so we can now put this number in the formula and then run the test. Okay. Let us run the test. Z equals excuse me, sorry. Equals, this is this right here. X bar sample mean, S bar, minus population mean of mu divided by the standard deviation or by the square root of n. Okay. And again, just refreshing your memory, the summary statistics we have our mean is 42,000, standard deviation is 5,230, sample size n is 30, and sample mean S by 43,260. So let's go and put them in and then run the test. Okay. Put in this formula. Okay, equals. We put this. Sample mean of 43,260. And a population mean of 42,000 divided by standard deviation of 5,230, but square root of n, or n is 30. So let us put this in the calculator. Let me write this down and then put it in the calculator. Z equals 43,260 minus 42,000 divided by standard deviation of 5,230 plus square root of 30. Okay, let's go and do it. Let's go and do it. I'm taking to the calculator now. And there's a calculator. Okay. Let's see. Let's see the calculator right here. Okay. Taking you to the calculator. Where is my calculator? Okay, this right here. So I can share it with you. So now we put the numbers in. Have okay. For the 260. Oh, sorry, my mistake. Let me make it the parentheses so that it will help make it easy for us. 43,260 minus 42,000. Okay, divided by standard deviation of 5,230 over. Please, can you mute yourself, please? Root of 30. Hello, can you mute yourself, please? So you get approximately 1.32. 1.32 approximately. 1.32 approximately. 1.32. So I'm going to copy this. Okay. And paste it in our main workbook so that we can now make our decision. Right here. Now paste this right here. Okay. Now, so this is our answer we have. So let us find the critical value. Okay. The critical value for alpha 0.05, the critical value, make correct note for it. Critical value, value. Now, because it is one tail, what is Z alpha? Z alpha, so alpha, right? Where equals. Now, this one, we have to get this one. Say for alpha 0.05. Remember, if it is Z alpha over 2, that means 2 tails. You use the method I showed you last week, P over 200. But this one is only one tail. So what you're gonna do now is let me before I can get if you remember the procedure chart, it is even whenever it's at the tail, you subtract from 0.5. So you're gonna do let me draw this thing first, then I'll show you what I mean by that. So this is what we have is positive and it's on the right side. The chart might look like this. This is how the chart will look. Okay, might be like shapes. I can make the chart right here. Okay. A little bit. And if you go down and see that this is 0, answer is 1.32, and make it bigger. I think I'm drawing that this place will not be good for it. So give me 1 minute. Hello, Father. Yeah, you can call log back. I'm at the lecture remote. Okay. And call back when I'm finished. This time. Yeah. So this is the chart. Let me show how the chart looks like. I'm gonna bring this down a little bit. Yeah, good. So now we have this insert. Let's draw the chart. It's gonna be like this. Out up. Okay. Now I'm going to now put this center line. The center line right here. Okay. Now this is the for 1.32 right here. See, that's what we're gonna have at 1.32. Okay. Now it's a greater than that, so you're gonna shed that side. Let me use the draw to shed the side. Okay. Okay. Now, anything that falls here, let me write it down here. Say reject. So this is the critical region. So anything that falls in that region, you reject. See, this is the critical region right here. Anything that the answer 4 in that region, you reject it. Now, because it is at the tail, we're gonna do to get the critical region value have 0.5 minus 0. Alpha is 0.05. Okay, that will give us 0.5 minus 0.05. Okay. To look at the calculator 0.5 0.5 minus 0.05, give me 0.45, 0.4500, which is 0.4500. Now, that will give us, I can just bring this down a little bit. Okay, and bring this down a little bit. Okay, make it right here. All right, I got it. So now from the which is this will give us equal. Now we look for this on the table. We put it on the table 0.4500. I'll take it to the table of normal distribution. 0.4500. We have 0.45. We got 0.4495. 4500. 4495 and 4505 as a closer. They both of them are equally close because this is 5 points away on the left side. This is 5 points away on the right side. So they're equally close. When they're equally close like this, we use the bigger one, which is this one here. Follow it to the left, 1.65. So give us 1.65. 1.65 is a critical value, 1.65. Now, that's a critical value right there. So we got our null hypothesis, alternative hypothesis, our critical value. We draw the chart, put our critical answer we got here. Then we run the test and got 1.32. We now put it here. Now, it's time for us to make decision. The decision is to compare the calculated value plus the critical value. Remember that I say that the decision criteria is this. Reject the null hypothesis if the calculated value is equal to or exceeds the critical value. So let's make our decision here. Again, this is a critical value, this is our answer. So decision here, decision. Okay, I'm gonna put them together here. Maybe I should move this down, right? No. Let me see if it will work. So let me move this because this place will not contain it. Okay, I think it will contain it. Okay, a little bit more. Okay, decision. Our decision. So the calculated value, the critical value equals 1.65. Okay. Then calculated value. Critical value, I mean, this is for Z alpha. Z alpha. Z alpha equal 1.65. The calculated Z. Okay. One we got from our answer is 1.32. Now, because this answer is less than the critical value, that means it's gonna be critical value. What I'm gonna put as critical value, 1.65 should be here, not 1.32. 65. So this answer is less than the critical value. That means it might be somewhere here. It fell in the acceptance region. So because it is less than critical value, we don't reject. Do not reject. Reject null hypothesis. Since 1.32, okay, is less than the critical value, less than 1.65. So that means if it's greater than 1.65, if it's equal to 1.65 or greater than than it, we'll reject. If it's not, like in this case, we don't reject. Okay, so that means we are not rejecting. We are not rejecting HO. That means since we are not rejecting HO, that means the claim this H1 is incorrect. So do not reject. So since we are not rejecting HO, that means H1 is not correct. So that means our conclusion now become conclusion. Conclusion. Okay. Now, remember the claim was that the salary of assistant professors in 1997 is more than 42,000. Okay. That was the claim. That's why you have HO meaning greater than 42,000. So that means since we are not rejecting HO, that means the claim is incorrect. What we're gonna say that we don't have enough evidence to support the claim that assistant professors earn more than 42,000 in that year. So what I'm going to write here is there is insufficient evidence to support the claim that the assistant professors to support the claim that assistant professors that assistant professors earned more than 42,000 in that year. There is insufficient evidence to support the claim. So again, let me summarize this. We make our hypothesis, identify our claim, get our critical value, draw the chart, then get our summary statistics, run the test by doing the calculations. Then when we finish, we compare our answer to the critical value. Our answer is smaller than critical value, so we don't reject the null hypothesis, which means that we did not reject this. That means this one is not correct. So we conclude that there is not enough evidence to support the claim that assistant professors earn more than $42,000 a year in 1997. Any question to this? Any question, guys?
No.
Good. So let's try the second one. This one is right. Let's look at this one. This one is mixed not really mixed, but two-thirds test. Okay, let me see how I can do this. It says here, it says the medical rehabilitation, sure you're seeing this. The Medical Rehabilitation Education Foundation report that the average cost of rehabilitation for stroke victims is $24,670. To see if the average cost of rehabilitation is different at a particular hospital, a researcher selects a random sample of 35 stroke victims at the hospital and finds that the average cost of their rehabilitation is $25,226. The standard deviation of the population is $3,251. At alpha 0.01, can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different from $24,672? See, can it be concluded that the average cost is different? See, is different. Different. They didn't say whether it is less than or equal to or greater, whether it's less than or greater than. They say different. Say different. So that now means we're not going to use we're going to use equal or not equal to. Different means not equal to. Okay. Solution. Let's state the hypothesis first. I have HO and H1. Okay. So it's a can it be concluded that the average cost of stroke rehabilitation at the hospital is different? I mean, different means not equal to. So, and you can only use not equal to in the alternative hypothesis. So I'm going to use it there. I mean, okay, not equal to not equal to 24,000 24,672. Then here it says mean is equal. Mean is equal to 24,000 672. Give me 1 minute. Let me check something here. Got something here. Something okay. Oh, here. All right. Anyway, remember this. Let's look at revisit the question again. It said the Medical Rehabilitation Education Foundation report that the average cost of rehabilitation is 24,000. So that means this is where the claim is. That was the report. That was their claim. So 24,000. That's the claim right there. Okay. That was a claim. Then this to receive the average, if the average cost is different, a researcher selected a random sample of 35 stroke victims at the hospital to find that the average cost is 25,226. The standard deviation of the population is 3,251. At alpha 0.01, can it be concluded that the average cost of rehabilitation at a particular hospital is different? So this is the claim at the beginning. The Medical Rehabilitation Education Foundation report that average cost of rehabilitation for stroke victim is. So that means this is our claim right there. I change this to unbold it. So the alpha is 0.05, 0.01. Okay. 0.01. And this is a two-tailed test because it can be greater than or less than. So I'm gonna call it a two-tailed test. So when you see that a null hypothesis is when you use equal and not equal to test to null hypothesis, that means you are dealing with two-tailed test. Now let's find the critical value for that. In that case, the critical value will be we found it the same way we did for confidence interval. Critical value, because it's two-tailed, is going to be Z alpha over 2. Z alpha over 2 because it's two-tailed. This time around it's two-tailed, okay? Alpha over 2. And our alpha is alpha over 2. Now, if it's 1%, that means 90. You're 90% sure, confident. So you're gonna be 90 over 200. That's P over 200. If you remember from last week, let me put a P over 200. Let me look at a P over 200, which means 90 over 200. Remember from last week, I say that percent is over 100, but now since I have two sides, from left side or right side is two-thirds. So yeah, that's why I'm using 200. This is just a shortcut formula for this. 90 over 200 from the calculator, we can find that 90, okay, 90 divided by 200, 0.45, 0.45, 0.4500. Now, from the table of normal distribution, we can find this. Let me adjust this first. Make an adjustment here. Okay. From the table of normal distribution, we can find this number that is correct, the Z value that corresponds to this. Z value that corresponds to 0.4500. Okay. We go to table 0.4500. Well, it's the same 4500. 4495. Okay. And 4505. Because we have 4500. Okay, give me 1 minute. Let me see. Yeah, 90 or 200. 4500. Yeah, that's what we got from the calculator. Yeah, 4,500. Okay. So now we have 0.450. It's not the same thing we have here. Yep, 450 is 1.65. 200, 1.65. So from the table, we have it here. 1.6450045. So there are two of them. I have 4495 and 4505. They are both of them are equally close. This is just a coincidence. Okay. We'll use this one. Follow to the left, 1.65. Again, 1.65. 1.65. Okay. Give me 1 minute. Let me double check something here. 1 minute. Oh, yeah. As a matter of fact, it is here. It is on the table. Let me scroll down all the way down. It's on the table, this table right here. 90. 90 is 1.6. I see 90 is 1.65. Okay, so we are good. 1.65. And that is what we have here. 1.65. Now, I'm gonna make this unboard this. Now, this is how the diagram will look like. Okay. You're gonna look like this. We're gonna have because it can be both sides. Because it says two sides. So you're gonna be plus or minus. Let me see if you can see if you are seeing this. Okay. You're going to be plus or minus. Let me put it right there by the side. It's gonna be plus or minus. Yep, plus or minus 1.65. It can be left side or right side. So that means here our diagram would be like this. Negative 1.65. You have 0, 1.65. Okay. So I'm gonna draw the shape. Okay. Oops, excuse me, sorry. Yeah, because the space, the space. Okay. Let me try and see if I can accommodate it here. Now, I'm gonna add the bell curve. Okay. See if I can accommodate it here. Okay, that's the bell curve right there. I'm gonna put the center line right here. Okay. Now I can, because it's both sides, the two tails. So this is the left tail, and this is the right tail. Okay. So anything that fall within this tail, these two tails, inside is the acceptance region. So do not reject acceptance. But outside these two region, you don't accept, you reject. And anything that if the answer falls there, you reject. So if it falls on this side, you reject. If it falls on this side, you reject. Okay. So that means we got reject here, reject here. So I'm gonna put the arrow to show you what if it's false. Anything that falls here, you reject. Anything that falls on that side, you reject. But if you fall inside, you accept. Okay, that's how it's. That's why it says two tails. Now, with this, we can now write our summary statistics and do the calculation. It says the mean. It says here that the Medical Rehabilitation Education Foundation report that the average cost of rehabilitation for stroke victims is 24,672. So the mean is 24,672. 672. Now let's select a sample of how many? Let's select a sample of 35 stroke victims and found the sample mean to be this. Okay. And it's 35 stroke victims. And then we have this mean first. Mean is this, then standard deviation. Let's put the standard deviation equals this standard deviation is this standard deviation is 3,251, 3,251. Okay. Now the sample of 35 of stroke victims we are selected, and the sample mean was 25,226. Let me write it down. Let me write it down. This one. Sample mean is 25,226. So we go and get it from the other workbook. Was this one will allow me to use the character there. X bar X bar equals 25,226. I'm gonna copy this and put it right there beside it. Okay. So I'm gonna put this right here. So with this summary statistics, we can now run a test. Let me write them my own down completely. It is 24,672. Standard deviation is 3,251. Okay. Now we have 1 minute. Okay. Now next is the sample size, which is 35 stroke victims. So let's go and put it and run the test, the formula. So again, Z, okay, Z equals, as usual, we have X bar, okay, minus population mean of mu divided by the standard deviation of delta, okay, delta over the square root of n. So that we can now put our values. Remember that from the summary statistics we have that some population mean is 24,672. Standard deviation is 3,251. Sample size n is 35. And sample mean for the 35 sample is 25,226. So we go and plug this in into the formula to get the answers. We have sample mean 43,260 minus 42,000. Oh, a mistake. It's a mistake. I'm putting the wrong thing. 25,226 minus 24,672 divided by standard deviation over square root of n, 3,251 over the square root of n, which is square root of 35, equal. So let me write this down, plug it in the calculator, and give the so we can generate the result. Z equals 25,226 minus 24,672 divided by 32,51 over the square root of 35. So let's put it in the calculator. Okay. Why is that calculator right here? I got 25,226 minus 24,672 divided by standard deviation of 3251 over the square root of 35. Give me 1.0081. So when you round it up, it's gonna give you 1.01. So I'm gonna put it right there. 1.01. 1.01. So I'm gonna copy this, paste it in the main workbook, which is 1.01. See? Now this 1.01 is the answer. You can see that it falls, this is 1.65. It falls, you get 1.01 before you get 1.65. So it falls within the acceptance region anyway. But anyway, we have the critical value as 1.65. Let's make a decision. Critical value. Value Z alpha over 2, which is Z alpha over 2. 1 minute. Z alpha over 2. Alpha over 2b, see the alpha right here, over 2 equals, we got it as, remember, if you remember, we got it from the table as 1.65. So we're gonna put 1.65. Okay. I'm gonna adjust this. So now our answer, which is the calculated value, calculated Z equals our answer, which is 1.01. So the answer is smaller than, again, this is just, it happens. It is smaller than 1.65. If our answer is bigger than 1.65, than the critical value, we'll reject. But here, again, it's smaller, so we don't reject. So do not reject HO. So that means, see, the claim is, HO is on the claim. Let's see, like here. HO says it, mean equals 24,672. That's what it says as a claim. So you say don't reject it. That means the claim is correct. Okay. Which means that we have sufficient, we don't have sufficient, we have sufficient evidence to support the claim that the average cost of rehabilitation for the stroke victim is 24,672. So conclusion, we have sufficient evidence, we have enough evidence to support the claim that the average the average cost of rehabilitation for stroke victims is 24,672. And that's it. So again, remember, we stated our hypothesis that identify the claim. Then we stated whether it's a 2-tailed test or 1-tailed test. It's a 2-tailed test. Alpha is 0.01. From there, we're able to get our critical value at 1.65. Put it on our charts. We got our summary statistics. We plot them in the formula and run the test to get 1.01. Then we compare it to the critical value. Our answer is smaller than the critical value, so we do not reject. Since we didn't reject, that means this claim is correct, because since the claim is on the null hypothesis. And that. Any question on this? Any question, guys? So no question. Good. Now, so this is when we meet next week, we start from z-test for the mean using the p-value method. Now, before we leave, I want to remind you, some of you who are not here before. Now, this is the makeup season. If your attendance score is up to 70%, then send me an email with the names of the 5 assignments you want to make up. Hello, can you hear me, guys? Hello?
Yes, we can hear you.
Okay, good. So if your attendance score is up to 70%, 70% or more, send me an email this week. Go to your grade book, check the assignment, 5, not more than 5. I can't do more than 5. So send me the email, 5 assignments you want to redo. Then before by Sunday, I will respond to you and tell you what to do to make them up. If your attendance is not up to 70%, don't bother to send the email. But what you can do is try to push up your attendance to 70%. Then you can from 9 to December. Then you can then request for makeup for 5 assignments. Okay.
Will that include any Pearson assignments, or is it stuff like classwork and homework that you've assigned?
Pearson assignment is included, yes.
Okay, awesome.
So,
Thank you.
so long as it's only 5. I can't do more than 5. Okay. Now, please don't go yet. Let me take your names. I have some names here that I haven't taken. I have taken some of you already, but there's some I haven't taken. I have Brooks. I have Eric already. Should I have Shode? I have Daly. I have Daly, right? Marcus Graham. Okay, I got Graham now. Graham. Maria. I have Maria already. Morgan Peacock. I got Peacock. Coleman. I got Coleman. Okay, Floyd. I got Floyd. Zakia. I got Zakia. Who else? Can you mute yourself, please? Okay. Gross. Harris. So now, when I call your name, you can leave. Brooks, Coleman, Kimura, Daly, Dumas, Zakia, Graham, Tamira Gross, Harris Tremaine, Jenkins, Jones, Kilu, McCoy, Peacock. Is there anybody here that I didn't call their name?
You didn't call me.
What's the name, ma'am?
Rachel Parrish.
Who again?
Rachel Parrish. I feel like you never called me for attendance.
Yeah, I thought we fixed it last time, right?
Yeah, but you didn't just call me just now.
Okay, so I thank you for letting me know. Yeah, maybe you are the one, because there's somebody that it was showing up here as iPhone. See what I mean? So
mine showed up as iPhone. It should be Sheree Curlew.
what's the name? What's the name?
Sheree Curlew. I tried to switch it.
Oh, Curlew. Sharia, right? I checked your name.
Okay.
I didn't hear my name either.
What's your name, sir?
Eric.
Huh?
Eric.
I mean the last name.
Washington.
Oh yeah, I checked it already. Eric.
Oh, okay, great. Thanks.
All right, but you got me right, Rachel Parrish.
Yes, I got Parrish now.
Are you assigning groups, or you want us to pick our own?
Yeah, I want you guys to pick your own. I'll give you that freedom to pick your own.
Oh, no. Okay.
Send me email. Do you want me to assign it? You know what? I don't want this to be delayed. So do it by yourself. No group.
How many? Oh, okay. Do it by yourself.
All right. Yeah. I don't want the delay. Yeah, because we don't have much time left. Okay.
All right. Have a good evening.
See you guys next week. Yeah. Okay, let me see what I got here.